Welcome back to math. We are going to begin talking about circles, and our first introduction to circles will focus on circumference. I imagine some of you know something about circumference, and we're going to have a little introduction here. And what I'd like you to do is pause the video here and just read those two short paragraphs. You should see some things that are very familiar to you, and it should be sort of interesting. So pause the video and read about Columbus and Eratosthenes. So it's actually kind of interesting because what happened was, if you think about it, Eratosthenes was pretty smart. He had two cities, Alexandria and Cyrene, okay, and they were 500 miles apart. All right, so the distance between those two was 500. Now the sun, look way up here by the date, is way up here. Okay, and when it was directly ahead in Cyrene, it was 7.5 degrees. He could measure that by shadows, okay, using trigonometry and shadows. We know those kind of problems. And he saw that this should really be like a 90-degree angle. Okay, it's directly ahead. If I were to move my sun where it should be, it's not going to let me move. Oh, maybe it lets me move it a little. Then this degree measure was 7.5 degrees. Okay, so what he was able to do is use proportions. We haven't really studied those yet, but saying that, you know, if in fact it's 7.5 degrees here, he divided 360, which is the entire number of degrees in a circle, by 7.5, and so he knew there were 48 segments, pieces to the circumference of the Earth, each of which was equal to 500 miles. Okay, so from this information, it was easy to show that it was 24,000 miles, and actually, the circumference of the Earth is 24,901. So he was really close for way back when, not having the modern tools we have today to do that. All right, so the first thing we need to do when we start any kind of new territory is we need to look at the vocabulary. And the main definition I actually neglected to put there, so jot a little circle word right above that, and we're going to define circle. Circle is all points equidistant to a given point. So if you think about that and you have point C, this point's the same distance as this point, the same distance as this point, the same distance as this point. And once you do that enough times, you will get a circle. So the radius is that distance. It's the distance from the center to the circle. The diameter is a chord containing the center. So let's go down and define chord. Chord is a segment with endpoints on a circle. And so then a diameter, those endpoints are on the circle, but part of it goes through the center of the circle. Circumference is the distance around a circle. An arc is a section of a circle. A minor arc is less than 180 degrees. A major arc is greater than 180 degrees. And a semicircle is 180 degrees. So let's take a look at our circle down here and see how this looks. So the circle is obviously, we'll call this O. We'll call this circle O. And if you think about it, it's represented by all the points on this. This is my circle. Okay, this is the center. And I'm going to erase this because it's going to get messy if I don't. Okay. This blackened area that I'll now color green is a minor arc. And every minor arc has an associated major arc. So the major arc associated with that would be this one. Okay, that's a major arc. If you think about what this segment is, this would have to be a chord. It's just Joe chord, not a special chord, has nothing in particular, just has its endpoints on the circle. But the chord that contains the center of the circle is the diameter, and then this is your radius. Okay, so that's kind of like our anatomy of a circle. Alrighty, so let's go on and do some problems. The formulas for a circle I think you have seen before. They're either pi d or 2 pi r. Okay, so it's either equal to pi, that's a pi symbol, times the diameter, or pi times twice the radius. Well, the diameter is twice the radius, so these two expressions are equivalent. Okay. The diameter is twice the radius. So if you change that around algebraically using the commutative property of multiplication, then of course you would get 2 pi r. Now, the thing you have to be careful of, there are 3 ways to express our answer. Number 1, they might say use 3.14 for pi. Number 2, they don't say anything. They just say round it, or they would rarely say use the pi button. They would just ask you to round it, in which case you should use the pi button on your calculator. Or 3, if they ask for exact answer or in terms of pi, you don't even have to plug anything in. You leave pi in your answer. So for instance, in number 1, or it asked me for the circumference, and I'm going to write circumference equals, and since they gave me the diameter here, why would I use any other formula than pi d? Okay, so the circumference is going to be pi times 8, and we always express that like 8 pi. Now, if they asked me to use 3.14 for pi, then I would do circumference equals 8 times 3.14, and that's going to be 25.12 feet. Okay, in the case of number 2, if they said to use the pi button and round, I would use circumference equals 8 times the pi button on my calculator, and I would get circumference is approximately, I have 25.13 to the nearest hundredth. Okay, feet. So you can see there's definitely a loss of exactness there. The final one, if they said leave it in terms of pi, would be this one, 8 pi feet. That's the answer if it was to be exact or in terms of pi, okay? Because if you think about it, pi is a number that repeats and goes on and on and on. We will do a little investigation of pi tomorrow, but in the meantime, I think most of you know what pi is, and so there's no way to represent it in terms of a number that ends. So in number 2, if I was asked to do it using 3.14 for pi, I would say, in this case, I'm going to use 2 pi r because they gave me r, so why not? That's going to be 2 times 3.14 times 3.5. And if you work that out on your calculator, you should get 21.98. Okay? So that would be if they asked us for 3.14. If they asked us to if they just said round your answer to the nearest hundredth and they said nothing else, then you would use the pi button. So if I use the pi button, try it on your own and see what you get. I got 21.99 meters. Now if that was to the nearest tenth, then I'd have to write 22.0 to the nearest tenth, okay? So that's a rounding lesson for you. If they asked for an exact answer, I would just say it's 7 pi meters. Okay, that's the exact answer. Number 3, give me the answer 3 ways. Pause the video here and give me your answer 3 ways. All right, so if you're back, the first one, if I use 3.14, circumference would be 28.26 yards. If I use the second method, which is the pi button, I would get circumference equals 28.27 yards. And if I did it exact, or in terms of pi, I would say it is 9 pi. Oops, C equals 9 pi yards. Okay? Those are my 3 answers. Find the diameter. You guys should be able to do this quickly. I'm not going to do that part for you. Okay, so I will write the answers. I hope you paused here. And this one, diameter is 18 units. and the diameter is 2 units. So 6.28 equals 3.14 times d, and divide both sides by 3.14. What is the radius of a circle with a circumference of 8 pi inches? So again, you would plug that in. They're talking radius, so I will use my radius formula, 2 pi r, and I would plug in 8 pi, 2 pi r, and then divide both sides by 2 pi. Remember, pi is just a number, okay? So I would cancel out my pi's, divide 2 into 8, and I would get r equals 4 inches. Good. All right, now the next two are kind of challenging, so I'm going to walk through them with you. If you feel like you can handle the challenge, which you should always try at least, you should read through them, try them on your own, and come back and get a few hints maybe, or move on with me. Okay? All right, the first thing I'm going to do is I'm going to draw a picture representing this situation. Well, I have Earth here. Okay, here's my Earth. It's got a lot of water and a little land. Okay, and my Earth. Here, my land is green. And then more water. All right, so there's Earth. Okay, now if you think about it, something that is orbiting around the Earth is going like this. Right? That's the orbit of something around the Earth. And it says the altitude, this distance here, is 280 miles. All right? The diameter of the Earth is 8,000 miles. So my picture is definitely not drawn to scale, but you will get the idea. The diameter of the Earth, this section here, is 8,000 miles. All right? And then this section here, it's still orbiting, is also 280 miles. So if you think about that, what I want to know is how many miles did the space shuttle travel? So I have to figure out how far it is to go from this point, for instance, all the way back around, okay, to that point again. The circumference of what it is traveling. And it does that 20 times, but if I can figure out once, then I can multiply it by 20. So the diameter of the circle that shuttle is making is 280 plus 8,000 plus 280. Now some of you might have gotten stuck up till this point, but maybe you could pause it here now and try the rest on your own. Okay, so if you add that up, the diameter of that circle would be 8,560. So the circumference would be pi times 8,560. So the question is, do we use 3.14 for pi, or do we use pi button? Well, actually, I'm going to ask you to do it both ways, because I'd like you to see how the difference works, and it's not that big of a deal to do it both ways. So the first way that we will do it is we'll use 3.14. Oops. And I got 26,878.40. Okay, and then I have to multiply that. The distance is going to be 20 times that number. And that's going to be 568 miles. Oops, that's a 6. Okay, that's the answer using 3.14. I would like you guys to go and figure out what the answer is with the pi button. Okay, so I want you to give me an answer with the pi button. All right, then we're going to, now if that one was a little confusing, maybe now you kind of understand the way to do it, and you can try the next one on your own. At least try part of it. It's a little different, but it has some similarities. Two runners are racing 4 times around a circular track with a circumference of 1,000 feet. So here's the track with 1,000 feet. All right, this is, and then it says the first runner will run on the line. So this is 1,000 feet, and that's runner 1. This is my runner 1. The second runner runs 3 feet outside the line. So the second runner is running next to him, going outside the line. And again, this is definitely not drawn to scale. So the distance here is going to be 3 feet. Okay, that little distance. How much more distance will the second runner cover than the first? Well, we need to figure out the circumference of that circle. Okay, so the circumference of that circle depends on either the radius or the diameter. Well, I know that this is 3 feet, so I would like to figure out this distance. Okay, I know that this little part of it's 3 feet, and I know this little part of it is 3 feet. What I need to figure out is what this part is. What is just that section? But I know the circumference of that circle. So I know the circumference equals pi d. And this is for runner 1. Okay? So 1,000 feet equals pi times d. Well, if I use 3.14 for pi, and again, I'm probably going to ask you to do this one twice and see what the difference is because it's kind of interesting. So I can then divide 1,000 by 3.14 to get D. So D for runner 1 is going to be approximately 318.47. Now I can just find out that the diameter for runner 2 is going to be that 318.47 plus 3 plus 3. So that's going to give me 324.47, and now I can find the circumference for runner 2. Okay, and I'll use 3.14 again because this is pi d, okay, times 324.47. So the circumference for runner 2 is 1,018.84. So and they run 4 times around. How much more distance will the second runner cover than the first? So the distance is going to be 4 for runner 2. 4 times 1,018.84, which is 4,075.36. And obviously the first runner ran the distance for runner 1 was 4,000. So if you subtract those two, you would get 75.36. Sorry, this pen is acting up. I don't know what's going on with it, but you get the idea. So that's feet, right? Now what I would like you to do is go back over that and use your pi button. Shouldn't be that difficult. It should only take a couple minutes to go through here and replace this and this. And that's it, really, with your pi button. And see what happens and see if you can tell me why it happens. Okay? So I want a pi button answer here, and I want a pi button answer here, and I want you to think about why that happened. And I want you to have a wonderful evening. Adios.